Good morning, sir. My name is Sohaile Otolontowa. Super Bowl ad price. The following graph shows the price for a 30-second Super Bowl and from 2008 to 2015. As what you can see here, I've made a graph that shows the corresponding datas. The question is, what was the price of a 30-second Super Bowl ad in 2013, round to the nearest tenth of $1 million? My answer is $3.8 million is an exact amount that the price of 30 seconds Super Bowl ad in 2013. Hence, if you will round it to the nearest tenth of $1 million, therefore, we will get 3.8, the same as the first value. Why? Because 3.8, the tenth number here is the value of 8, which has no any numbers that follows after 8. So therefore, you could not round it down nor round it off. But in rounding off the numbers, you can only round off the numbers if only then the numbers that follows a particular number is greater than or equal to 5. Then, if only then the numbers is lowest than 5, then you cannot round it off anymore. The second question is, in 2015, about 118.5 million people watched the bowl on television. What was the price viewer that was paid by an advertiser that purchased a $4.5 million ad, round to the nearest cent per viewer? The given here is we have 118.5 million people and $4.5 million purchase, and we are about to find out what would be the price per viewer. So therefore, I conclude that the dividend is $4.5 million and the divisor is 118.5 million peoples, since we are getting the value that per viewer paid off. So basically, I use the uh, uh, basic formula, which is I only divide 4.5 by 118.5, and I find out that I got a result of 0.037. So since I am about to round to the nearest cent per viewer, then uh, the thing is I've got 0.04. Why? Because the cent here is number 3. Then 3 follows by 7. So therefore, it means 7 is greater than to 5. So it simply means that I should round it off. So it becomes 0.04 centavos. Let j equals negative 2, 0 to an age equals 468, and define a relation v from j to h as follows. For all x and y is an element of j times h, and x and y is an element of v, means that by this statement, x minus y over 4 uh, um, is an integer. The question is 2 related to 6, and is negative 2 related to negative 6, and is 0, 6 is an element of v, and is 2 and 4 an element of v. I provide some definition or answers that supports my claim. Answers. For letter A is 2 related to 6. Hence, I let's assume that 2 equals is an x and 6 is our y. So we have to substitute it to the um, constant formula, which is x minus y over 4. So we will be having negative 4 over 4, and the result is negative 1. So therefore, since negative 1 is an integer, 2 and 6 is an element of V, and thus 2 is a relation of 6 is true. The other question is negative 2 a relation of negative 6? The result, as what you can see, since negative 6, our y here is not an element in age, which we have age equals 4, 6, 8, and negative 2, negative 6 is not an element of V, and it's not true. Thus negative 2 is not related to 6. Is 0, 6 is an element of V? Let x equal 0 and y equals 6. So we only have to substitute all the given value. So we will be having a result of negative 6 over 4 and equals negative 3 over 2. Hence, negative 3 is an integer. So therefore, 0 and 6 is not an element of V. Is 2 and 4 an element of V? Let x equals 2 and y equals 4. So yes, as usual, we have to substitute the value. So we will be having the result of negative 2 over 4 equals negative 1 half. Hence, 1 half is an integer. And 2 and 4 is not an element of V. So therefore, 2 and 4 such that it is an element of 2 and 4 is an element of V is not true. For letter B, write V as a set of ordered pairs. V contains all ordered pairs x, y is an element of G and H, for which by the statement of x minus y over 4 is an integer. And thus, if the differences x and y is divisible by 4, V then contains all previously mentioned ordered pairs as what you can see in the solutions provided. V equals negative 2 and 6, 0 and 4, 0 and 8, 2 and 6. For letter C, write the domain and codomain of V. The domain is negative 2, 0, 2. Codomain is 4, 6, and 8. For letter D, the domain and codomain, I draw an arrow to illustrate the domain and codomain, which you will find at the sets of ordered pairs.